Hello, and thank you everyone for attending today's webinar, Using Raspberry Pis to Create Powerful, Low-Cost Solutions with Galil Controllers, brought to you by Design World Magazine and Galil. We'd like to thank our presenter, Troy Miller, for being here today. I'm Mike Santora, Associate Editor for Design World Magazine, and I'll be your moderator. Just a couple of housekeeping details before we get started. You will see several boxes on your desktop, all of which can be moved around to suit your preferences. Initially, the Q&A box is at the lower left, and this is where you will enter your questions for the Q&A session. Another box to note is the additional resources, initially at the lower right-hand corner of your desktop. These resources are for your information needs. We also have a tweet box right on the desktop, so feel free to tweet any interesting points right from there. There's also a list of hashtags for you to use too. Troy Miller joined Galil's Applications Engineering Department in 2014 before coming to Galil. He worked on a project for a school in Uganda to design, build, and install a solar microgrid system using the Raspberry Pi. As one of Galil's software experts, he has been part of a team to define, develop, and test software solutions. Troy holds a bachelor's degree in electrical electronic engineering from California State University, Sacramento. And so, without further ado, here's Troy Miller.
All right, well, thanks, Mike. Appreciate that. Appreciate everyone for being here today. As we'll see, I think the Raspberry Pis, it's a great little device, and I think you're going to see it can really be useful when you're starting to look at developing some really cool, really useful applications. So what we're going to do today, I wanted to just cover some of the basics, kind of high level. We're going to talk about system design overview, and I also want to get in some details, so give you a direction. So if you get one of these Raspberry Pis in your hand, what can you start to do with it? Taking out of the box, what should you expect to have to do to start getting to interact with it, to start to become useful to you? So I want to talk about a little bit about those things. And then what I think is everyone's favorite part, we're going to talk about some example applications. We're going to get into a simple application and a couple more advanced applications. So I wanted to get into that a little bit as far as talking about motion control systems in general. The host PC in a motion control system is kind of the central point for all communication throughout the network. Really, there's also one central point where the user interaction, and that's also at the host PC. Now, the motion controllers and the PLCs, it's what's going to really actuate the mechanics. It's going to move the hardware around, essentially do the heavy lifting of the application itself. And the PLCs, it's going to handle process flow, so if you need different pieces to go in different places, you need to move stuff around your plant, et cetera. That's what the PLC is really going to be useful for. The key here is each component is really a specialist at its task. The generalist in the room, though, is really the host PC. It has many tasks to cover. And so general purpose, it has to do many things. It's not particularly specialized at one specific thing, but does a lot. And what that does is that really gives you a lot of options. So for instance, you have the ability to run many different software options. You can run web servers. You can run databases. You can run other software packages. The priority for a host PC is really given over to support a wide variety of hardware and software. The host PC also connects you to a company network. All the communication is going to go through this equipment. This is kind of the point where security is really handled. If your host PC is secure, then all of your automation and your other equipment is also secured. Now with the user interface can take many different forms. Classically, it's been a monitor, a keyboard, and mouse, and that's how you interact with your application. There's also the ability to get touch screens, and even something a little bit more exotic, like some kind of a web interface. This user interface is really what's running on the host PC. Now the host PC is really dealing with high-level commands, dealing with synchronizing different devices. It's gathering data from the different system nodes, really providing an extra layer of safety and monitoring. Is doing all this throughout the network. So the general purpose computers, they cover a lot of ground in the application. but what they lack is really a specialty to perform motion control. This is really where the Galil controllers and PLCs can come in your system. For Galil controllers and PLCs, we're talking about controlling a position, velocity, acceleration of your various motors, of your various actuators in your system. You take in a variety of feedback, whether it's different encoder types or different signals. That's feedback into the system that allows the controller to perform the deterministic task of maintaining those positions. Deterministic is really just running on a specific loop, a servo loop at exact intervals. That's really what's required to keep in your control, overall control of your system. So what's nice about the Galil controllers as well and how it kind of fits in is you have the ability to run programs locally on the controller, or they can actually communicate with the greater system. This is really where the Raspberry Pi can become part of a greater part of the system in this instance. The Raspberry Pi, what is it? It is the single board PC. It has a couple different models that's available. Basically, there are different form factors and connectivity options that you have with the Raspberry Pi. For all of them, you get a powerful processor, you get plenty of RAM, and the networking connectivity really is what allows you to use this as a gateway to your overall network. As far as the user interface goes, you have all these options that you have available. You can plug in your USB keyboard and mouse. It even has a display interface, so now you can connect in a touch screen right into the device, and now you have a working touch screen attached right to this little PC. There's all sorts of programming options available. A couple listed here, C++ and Python. Python's just a real easy language to use. It's actually one of the most common, the more common programming languages that universities are using now. And it's because it's so simple. And so we're going to talk a little bit about that. So both of these languages, they run on the Raspberry Pi. So let's say you go ahead, you order one of these. What are you expecting? What should you be expecting to work with one of these devices? Well, we have a couple links that we want to show you to. If you, after the webinar, head over to galil.com/Raspberry Pi. We have some resources there. We'll also be updating that page as well. We'll talk a little bit about that later with some additional information. But at a minimum, you get a Raspberry Pi. You're also going to need a micro SD card, and that's really what's going to hold the operating system. You're actually going to download an operating system image, and this will be from the Raspberry Pi website. It's a version of Linux that you download. You're basically going to move that over to the micro SD card, and that's how your operating system is going to run. So there's actually a couple of specific programs that you can get to run in Windows, and just to make it easy to load this operating system image onto the SD card. It's called Win32 Disk Imager. It's a free download. You can head over to their website and download it, and when you download the Raspberry Pi OS image, you can use it, select the image, select your micro SD card, click the right button, and now it's going to push this image onto this card and make it all ready to go. You're going to take the card out when it's done, plug it into your Raspberry Pi, connect to any other hardware. So for instance, the easiest way would be just to grab your keyboard and mouse and your HDMI monitor, plug those into the Raspberry Pi, and then just hook up your power. It's like a micro SD, or it's a micro USB cable. You plug that in. I think you need about an amp or so of current on your power supply, and you're going to boot up into this operating system screen on the bottom left-hand side. So there's really kind of two main ways that you can interact with the Raspberry Pi. The first one, as I'd mentioned, through this keyboard and mouse. The second one, which is a little bit more abstract, is called headless control. And basically what that means is all you have connected to the Raspberry Pi is just the power supply and an Ethernet cable. And if you have a network address, if you have an IP address assigned, you can now connect directly over the Ethernet network with something called SSH, or Secure Socket Shell. You can get a program for Windows, and now you essentially open up a socket to the Raspberry Pi, and you can begin sending terminal commands to it and essentially control it remotely. So it even reduces the cost. You don't even really need a keyboard and mouse anymore. You just use your existing laptop, your existing desktop, and it's nice. You have some tools. You can use that Ethernet connection as your main conduit of transferring data back and forth. You can use the file transfer protocol, pull files from it, push files to it. Another cool feature is this thing called apt. It is a software management tool, and it basically puts a bunch of things together for you so you can install software with only a few commands. And it just downloads it from the internet, installs it, and gets you all set up. So we're actually going to use this apt program. It's part of how you would install some of the free Galil software, the communication tools that we have available. So the Galil, we actually have some software packages. It's a programming API, or application programmer interface. It's called GClib, available on our website for free. And this makes it easy to communicate with Galil controllers and PLCs. Now, this is nice because it provides you a library of functions to connect and communicate to the controllers. It's small, it's efficient, and the great thing is the Raspberry Pi is supported. Another thing is that's supported is it's written in a low-level language, such as C. Basically, now we can have these things called wrapper functions, make other programming languages very easy to use as well. Python is supported in this way, so you can download this Python wrapper, and now you can interact with the controllers in this very easy-to-use programming language. So we've talked about several different components here. Let's see if we can kind of put it all together, just that system overview. But what does this physically look like now? Well, now we have our host PC, and we can get our free Galil software to allow these communication pieces. We can have active communication between the Raspberry Pi and the Galil controllers and PLCs. The Galil is really going to handle the motion elements, the I/O elements. Each is doing what it's good at. You have the general computing linked up with the real-time computing, and you can really make a powerful application through these combinations. So, what is this going to look like? What is it going to look like in real life? So that is where we're going to talk about some examples. We have a very simple application. Let's see how simple we can make this. We're actually going to go through that. We also are going to add some complexity and some more features. Let's say we want to have an operator control it with a touch screen. So we're going to have a single access application in this example. And then the final example is we're going to have a more complex, kind of fictitious automation machine. What can we do? Let's see if we can stretch the boundaries a little bit and design something that's really feature-rich, lots of motion, coordinated motion, involving many different systems. What can we do here? So we'll get into that one. So for our simple example, again, simplicity is going to be the key thing for this one. We're going to have one of our Rio PLCs. It's going to read an analog input. We have an attached signal conditioning board that does everything you need to connect a couple of thermocouples, and we're just going to read those thermocouples, do a little bit of math on it, store it to a file, and that's going to be available. That will download from the controller over FTP, or File Transfer Protocol. Just an easy way to bring it over. And this is going to be in this headless configuration, so there's no other hardware that's needed, just the Raspberry Pi and the Ethernet connection to your local network. And we're actually going to use Python to develop this application. And it's so simple, I actually wanted to show you code right on these slides and kind of walk you through it. So if anyone's a programmer, I think you'll be able to follow this no problem. If someone's not too well versed with programming, I just want to walk through just a few pieces just to show you what's happening and how simple this really can be. So if you look at line 5 and 6 here, line 5 and 6 is really creating a file to start storing our data. Jump down a few lines to line 11. We're using some of the GClib, some of our Galil library functions, to open up a connection. We're opening up a connection to our controller, and then we're starting a loop. The whole goal of this is to gather data, right? So the loop is going to start up in line 15. It's going to just open up a loop, and line 16 is where we're going to go ahead and grab, and we're going to send a command to the controller, and we're going to grab that analog read from our controller. We're going to apply some math to it, calculate the temperature, and we're going to save that entry to a file with the timestamp. That's done down on line 12. So we're going to do that. Now we need to have a little bit of a timer in there so that we're not constantly reading this. We set this up. It's going to run this code about every minute and go ahead and grab a new entry, save it to that file. And it's going to continually run until we cancel this. So it's going to continually run and gather data on this little sensor. So let's see what this looks like in the end. Let's see what this shows us. So we're reviewing this data. I went through, grabbed this file from the Raspberry Pi, transferred over, and just put it in spreadsheet software so we can visualize it on the screen. So you can see the temperature. This is just the thermocouple sitting on my desk. You're looking at it sitting right around 70 degrees. This is nice. This tells me that our air conditioning in the building is indeed working. So this is a simple example, but what else could we do with this? I think you can start kind of thinking of some ideas. What else could you really do with this? Well, let's expand on this a little bit. So we have temperature. We can involve other sensors. What about humidity, energy usage, pressures, tank levels, flow rates? Think of a sensor. Does it have an analog or digital interface? If yes, let's hook it up. We can do encoder counts. We can take those encoder counts. We can calculate velocities. We can connect to multiple PLCs at the same time from one Raspberry Pi. So this can really start to expand. One topic I wanted to bring up is this new concept of this Internet of Things. We're talking about toggling outputs, getting inputs from the Internet. When you have a gateway set up, you can allow your Raspberry Pi to be this IoT gateway. And now you can have it send commands on demand to start doing things in the real world, actuate things. You can read inputs right from the Internet. It's kind of a new thing that's been developing lately the last couple of years. Something else that I want to mention is the SCADA nodes. You can actually set up a SCADA data source with the same type of configuration. SCADA stands for System Control and Data Acquisition. You can use the Raspberry Pi and the Rio as a SCADA data source. Now if you have these distributed around, let's say, your factory, say around your plant, now you can have this feed a SCADA system that's already existing and begin to have an operator monitoring all the different variables that are going on in the plant. So kind of the first example, it's really simple. So we use some free software. We use a PLC. What might a system like this cost you? So the bottom line on this one is you're talking about $250. Gets you a PLC, gets you a host PC, and using some free software tools, not needing any kind of an interface really helps the cost even further. This can be a really cost-effective solution for an OEM application, especially to satisfy any kind of data logging needs, something that doesn't need a whole lot of hand-holding. Just set it up and let it go and let it gather data. So this is a really simple example. Let's see if we can add some additional complexity through our next example. So on this one, we're going to add a single-axis motion control to this one. We're also going to have the operator. They're going to be setting up the machine. They're going to want to use a touch screen, and it should be easy to control, just as you would control or just as you would use, let's say, a smartphone application. So we're going to make a real simple cut-to-length application. So in this application, we see it's already done. It's not something that's fictitious. This is actually done in place here. You can see here the operators can use the touch screen. You can see that on the bottom right. The Raspberry Pi is actually on the back. It's connected to the back of that. So the host PC is there as well. It's connected to the greater network through that network switch you see on the right. So you can start to communicate through it. You can have essentially a portal outside the room if it's connected outside the room. And it's also connected to the single-axis Galil controller. That one there that you see is the DMC 30017, which has an integrated stepper motor driver. It is now driving the stepper motor that's connected to this linear stage. Now you have an application with a touchscreen, with a controller, and now you're moving something physical back and forth. So let's go ahead and jump into this application. Let's see what we have. Here. We're getting a little bit more advanced in our software side now. We're going to still use Python, and we're going to use it in an event-driven fashion. So when you interact with the user interface, it's going to call code to do something for you. We're going to use this through a library called Kiwi. And it is an open source user interface library that allows you to develop applications that act like smartphone applications. So it has a bunch of the widgets that you need. You have, sliders and buttons and switches, text fields, all the little pieces that you need to put together a screen. And when you push a button, you can now call a piece of code that then responds to do something, update the screen, send commands to the motion controller, and really allow the operator to control the machine through this touch screen interface. So with these tools, the operator should be able to easily be able to run this application. That's really the goal here. So let's take a look what the operator has to work with. So this is the controller selection screen that was developed. And it's basically just going to go out, check to see if there's any controllers on the network, and then list them there. So you can identify which one you're working with. If you have multiple, you could select between those. If the operator were to, say, click this button here and select this DMC 30000 controller, this is what they're going to get. You can see the screen on the right-hand side. This is what they're going to see, but what's happening behind the scenes. So when they tap on that, the code on the top left is going to run. And what this is going to do, it's going to set up the screen a little bit, you see on the bottom right, but it's also going to set some things up in the background. It's actually going to download some DMC code, some Galil DMC code to the single-axis controller. And what this is going to do, when the user moves that slider, it's going to set the position of the stage. What that's doing is that's actually sending a variable down to the motion controller to set its new position. Instead of moving that slider and then waiting until it finishes finishes where it's going, and then if you move the slider again, what we want this to be a little more responsive. So the code that gets downloaded actually enables what's called position tracking mode. So they can move the slider back and forth in different positions, and the motion controller will automatically move and have the final destination set. So it's always going to the final destination, really feels responsive to the operator. So when the operator is ready, let's say they home the axis to get everything that they need, they're going to go ahead and click that cut to length link over there on the right-hand side of that screen, and that's going to bring them to the cut to length application screen. Now this is really where we've limited the operator to interact with only the variables that they need to run their application. So this is not overly complicated. They can enter in the number of units they need. They can enter in the length of that particular one. This could be simplified further by allowing drop-down boxes of predefined settings. Really just up in the air. You can really do a lot of stuff with this. This has the ability so you can constantly get updated displays from the screen, where the motor location is, where is it at in its cycle. We actually do have a video of this available on our website. I want to direct you to that as well. If you go to galil.com/raspberry-pi after the webinar, go ahead and check that out. You can see this in action. And it really is nice. You can have essentially a smartphone simple application that an operator can use. If they need to be remote, this could be over Ethernet. This could be put in a different room, and they can interact with it. They can see live what the application is doing. So there's really a lot of flexibility in here. So we've added a little bit of complexity. We've added additional motion, and we've added some software elements. So with this complexity, how much is this application going to cost us? So for this kind of application, For less than $600, you can get a touchscreen HMI, human-to-machine interface. You can get a single-axis motion controller with a built-in amplifier. Software is going to be all free. You're going to develop that. Compare this against, some of these $600 touchscreen laptops that are currently on the market. For that kind of pricing, you're now down the road of really developing out and having the hardware pieces for putting together an application. So for the next example, I wanted to add a little bit more flavor. So let's talk about this automation machine that we're designing. We're going to have multiple axes of coordinated motion, multiple PLCs, and we're going to make a Raspberry Pi making a Raspberry Pi. So I thought this would be a nice example. We'll kind of flavor our example here. The Raspberry Pi, the actual PC, it's going to be running the show. It's going to keep everything safe, and it is going to be database driven. The key here is really adding an element of data automation. We're trying to push the boundaries a little bit more. What else can we do with this since we have this network interface? Well, now we can have this database. It can drive and push data into our IT systems, our billing systems, our bill of materials systems, our client-based systems that really can start interacting. You can start customizing your machine, taking individual orders, customizing orders, all sorts of stuff. So this is done through this database-driven interface as you're collecting this data. Another piece that's really important to this is you now can have the option of having a web-based user interface. Now you can have managers, you can have accountants, technicians, can all view what's happening with our little machine here, and they can view it right from their tablet, right from their laptop, whatever they want to do. So in order to accomplish a goal like this, we need to kind of break this thing up a little bit. So what are we going to do? We are going to have the first PLC. It's going to handle all the materials, going to get those in position for our machine. It's going to get that ready for the motion controller to do all its coordinated axes to make our Raspberry Pis. And once that's finished, once it's all baked, once it's all ready to go, it's going to send those out. And the second PLC, it's going to handle all the material unloading and the inspection process, make sure that it meets all of our quality standards. We're actually going to talk about the workflows of this a little bit here. So here's a quick little workflow on what this PLC might be doing. Simply put, we're checking inputs, we're applying some logic, and we're setting some outputs. We're checking things. Do we have enough Pi tins? Are there enough raspberries? When it's ready to go, are we moving those Pi crests down these conveyors? Are they going in the right direction? If there's any issues, we're sending error reports up to our Raspberry Pi PC. It's really just trying to get the product close to our motion controller so we can apply the process. So now that our Pi crusts, our raspberries, are all ready to go for the motion controller, what is the motion controller going to do? We have a couple options. The motion profiles themselves, we can actually have stored on the motion controller. We could also have them loaded on demand through the Raspberry Pi. And there's really a lot of flexibility built in here. If you need something to do something that's custom or one order is different than another, that's where you can have some flexibility and have that streamed to the controller right from the Raspberry Pi based on the order type or whatever it needs. But this is the same thing. It's checking if there's any errors, it's sending that on. It's bringing in those profiles, it's applying the process. It's cutting, squeezing, moving, overlaying our pastry lattice, putting it into the oven, monitoring that process, and then when it's done, pops it out and sends it on to our second PLC. It's handling the inspections. Same thing here, setting inputs, checking inputs, setting outputs. Does the Pi weigh the right amount? Does it fit into the packaging? Does it meet our quality standards? All that kind of stuff's happening on this PLC, and it's also sending those updates back to the Raspberry Pi is really what it's doing. So these three devices, you can see it's sending a good bit of data and back to the Raspberry Pi. So what is the Raspberry Pi doing while all this is happening? It's really doing the orchestrating of all the different systems. It may be checking and waiting for customer orders, checking your statuses and receiving error messages from all your PLCs. If it finds a fault, guess what it can do? It can stop the different systems to keep everything safe, all the while updating the user interface. You really want to be able to take in those orders, read reports, get the status information from the devices, notify the users, update the databases, do anything else with tracking, send things on, and if there's other reports, just data reports in general, those can be done. That's all happening on the Raspberry Pi. So how would we need to set up this Raspberry Pi in order to get our little machine working? Well, we have a lot going on. There's a web server. There's a database server. It's acting as a networking host, a file server, and this is all free software that's available that you can download and install on the Raspberry Pi right now. With all this additional complexity, it's really developing this into a server, a fully featured host that's doing a lot of things. And now a user, they can tie in, they can bring up their tablet or laptop, tie into the web-based interface and go ahead and monitor the controllers, monitor the systems, and really be able to send these, interact with the controllers at a high level, starting these processes off. So I put together a couple things of what this web-based application might look like. And these are just a couple mock-ups. The top left here is just kind of like a sample dashboard screen. It's just using some of the latest, web-based technologies just to bring in a really slick-looking dashboard. You're looking at it; it's got a bunch of data widgets, and it can show you your high-level components of your system. How many products have you processed? How many orders have you taken? What has your production been looking like over the past couple months? It can really show you whatever you need to show you right from a main kind of heads-up display kind of dashboard. You can have other screens as well. Let's say an operator wants to use this. They can have their different functions, their different buttons, or can be available to control particular machines. It could also be used to add, to create different orders. How many pies do we want this thing to make? We can add in specific orders, put in different variables. It's all stuff that can be done on the web server. So we've added a bunch of axes of motion. We've added a ton of software features. So how is this going to affect the price of this particular application? So for less than $2,700, we're talking about getting 8 axes of motion with amplifiers. We're talking about getting multiple PLCs. The Raspberry Pi is really just running the show in this case. And one thing I want to mention at Galil, we actually have a price guarantee. 100-piece prices for our controllers, we'll be able to beat a 100-piece price for an equivalent controller. That's something that we stand by. So if you have questions about that, feel free to let us know. So what else can we do with this example? We kind of push the limits a little bit on software and on features. Really, what else can we do? Well, we can really do a lot. As I kind of say, the sky is kind of the limit. What do you want to develop in this case? I think the winning combination, though, is combining the motion controller, that'll do the heavy lifting, and combining that with the Raspberry Pi. And that's really going to do the monitoring, the supervising. It's going to do the high-level communication elements. And that's really what it's designed to do. I really think the Raspberry Pi can be a good piece to the system. So when you have the Raspberry Pi, its role, it's going to be able to control your equipment from a single source. Its keys are the flexibility, its versatility. Those are some of its major strengths. We're talking about a lot of different user interface options. You can have a touch screen. You can have keyboard and mouse. You can do a web-based interface. You can have all these options available, and all sorts of software is available, including databases, web servers, math programs, different programming languages. There's really a lot that you can do here. The one thing that the Raspberry Pi is not well suited at is the real-time operating system required to actually control physical hardware. this is really where the motion controllers comes in. It's going to handle all the details required to handle your motion, do all your servo update loop. It's going to do all your tuning for high performance, make sure it gets done correctly. The keys for the motion controller side, when you're in PID control, when you're in this kind of environment, is repeatability and reliability of your application. You want something that's going to be able to keep control and maintain control, and that's where the motion controller comes in. That's what its strength is to do, is really keep your physical devices moving into the right place. So it's really focused on that particular goal. So how can we kind of bring these together? Well, that's through what the software does. This is what really brings the two worlds together. Through the Galil software that we have, it makes it really easy to bring these pieces together, and now you can have your mechanical systems accessible outside of just your local network or just your local connections to the controllers themselves. And really, there's so many options. The challenge is really finding that balance between features and simplicity. What are you trying to do? What do you need to do? How can you put these pieces together so you get features that you need and you get your application working, but keeping it simple and keeping it effective? And so the Raspberry Pi, there's through the advancements in computing, it really had this device. It's really an inexpensive device, and it has so much potential. It really brings the price down for its capability. You pair that with Galil motion controllers and PLCs to do the heavy lifting, to do those more critical pieces. And what was not possible before is possible now by really combining these technologies. And I think you'll see, the proof's kind of in the pudding. You look at some of these pricings that you have, it can really lower the costs. And so I think you can see you have a very powerful process. You can put together these components together and have a really excellent product in the end. So I think we're going to move on to some questions.
Thanks, Troy. We're going to open it up to questions here. So we'll start with, let's see. First we have, where can I download the source code from your demo applications?
So that's a good question. So we will have the source code for these demo applications that we showed on this webinar. They're going to be available at the Raspberry Pi at galil.com/Raspberry Pi. There's also a lot of other resources available in our download section. I want to direct you to that. So under our download section, we have an API section as well. That's where you're going to look and see some of our other software packages that we have. So really those two locations are going to be your kind of main source for looking at either the source code from the demos, but also other resources that we have available on our website.
Okay. Now, if somebody wants to work on their own program, where can they go to learn more about programming on the Raspberry Pi and whatnot?
That's also a good question. So I'd mentioned this a little bit before. The Raspberry Pi is really a large community of developers. People have really jumped onto this, and there's a lot of support online. The main links is going to be the Raspberry Pi Foundation website. There's going to be a lot of resources online there. We'll have links to that on our page at our Galil website. There's so many resources online for learning programming, for learning the Raspberry Pi. You'll be able to jump on there, use the forums to ask questions about your applications, about your programs you're trying to write, and using those resources really where I think you're going to find, how you can, really learn and develop your skills in working with Raspberry Pi.
Now, you mentioned this, you touched on it briefly a few moments ago, but maybe you could circle back and tell us a little more about when using Raspberry Pi would not be appropriate.
Let's see. So I think for that one, where you'd want to take a look at and really show some caution with using Raspberry Pi would be, if it's environmentally, if you have a situation where things are not going to be environmentally sound. There's going to be harsh conditions. It is a general purpose computer. It's not a robust, solid, piece of electronics. So you have to take some care in making sure it's protected in that way. The other place, it may be, if you're not comfortable yet developing in a Linux environment, if you're not developing with, command line with some of these tools, the Raspberry Pi may be more of a stretch, maybe more of a challenge. And so I would also, maybe take a look at that and see, how much you want to dive into some of this stuff.
Sure. Troy, which Galil controllers can be used with Raspberry Pi?
Yeah. So what's nice is with our programming APIs and the communication libraries that we have, all of our current products are supported. Those are all built into those communication libraries. So any of our current generation products that the Ethernet-based controllers, you can head to our website and look at our motion controllers page, look at our PLCs page. Anything listed there under current generation is going to be supported and you'll be able to communicate with it through the Raspberry Pi.
Okay. The next question we have coming in, it says, what touchscreen did you use for your second example?
Yeah, so the nice thing about that touchscreen is that's actually the touchscreen that was licensed or produced from the Raspberry Pi Foundation. So it is the official 7-inch touchscreen, and it's amazingly only $60 with a direct cable connection. And you just take this ribbon cable and you connect it from the Raspberry Pi right over to the touchscreen, and it's done. Like, it's set up for you. So it's super simple to integrate, and $60. It's I don't even know how they even did that, but $60 for this touchscreen, and it just hooks up perfectly to the touchscreen.
Okay. So the next we have is, does Raspberry Pi have its own language you can use somehow?
Yeah, so the Raspberry Pi, it actually is running a Linux operating system. So anything that you can run in Linux, anything that's been compiled, what's nice about Linux is most of it's open source. I didn't actually touch on this before, but if you have a particular software package that you like to use, and that can be open source, you can actually many times customize that to your needs. So a lot of things are developed in C or other low-level programming languages, and those can be essentially compiled, can be modified and compiled right on the Raspberry Pi and executed right there. So it's not a particular language. As far as the operating system goes, the operating system is this version of Debian. They call it Raspbian. And so if you know Debian Linux, it's very similar to that. It's very similar to like Ubuntu if you're used to that one. Some of the commands are the same between those. So I guess that's how I would probably answer that question is it doesn't have its own language. It's a Linux operating system. But the cool thing is, you can look up those commands. You can look up and get help online for how to use those Linux commands specifically with the Raspberry Pi. So the community is really useful and helpful.
Okay, so the next question we have is, with a DMC and 2 RIOs, do you have code running on each of the devices, or is the Galil code only running on the DMC?
So with my example, the third example, it's really was more of a kind of a fictitious example. The answer is yes. You can run anything. You can run code on the PLCs. You can run code on the motion controllers. It can all be communicating with the Raspberry Pi at the same time. So it's really dependent on your application. If you have a specific application and it needs to have code that's running on the controller, then yeah, you can download some code to run on there. You can even have it download specific things if you need to have specific things changed out or variables sent down to modify the behavior or to change how the outputs work. That can all be done from the Raspberry Pi directly, or you can have code running on the RIOs or the DMCs or the RIOs and the DMCs. However is going to be a best fit for what you're trying to do.
Okay, Troy, so the next question we have for you is, in your opinion, is the Raspberry Pi and other maker community hardware going to be reliable to use in commercial products and environments?
Yeah, so that's actually a really good question. So I think there are some things that you can do to make the hardware more reliable. Some things you'll do if you're familiar with this kind of hobbyist environment is the use of the micro SD card. People will point to reliability issues with the number of read and write cycles on the flash memory. And if that's an issue, for instance, you can modify this a little bit, and you can actually run the operating system from a USB hard drive. And now you're no longer reliant on the actual micro SD for the operating system. That could increase the robustness of the application. But I really think all the components that are there on the Raspberry Pi, they happen to be just a nice package, and they're nice and flexible. But they have the plans there. They have a lot of their stuff is open source. So if you're talking about making your own product, your own OEM application, there's even options where you can make your own board that's based on the Raspberry Pi, and it's all integrated. And so at that point, you have complete control over its reliability. I really do think the costs are really coming down. So I think the future really is going to be, these devices are going to be more and more common. These price points, I just think, are unavoidable. When you can make these devices and these features that you can get. So I really do see it as happening in the future.
Well, thanks again for all the great information today, Troy. I just want to remind everybody that if you have any additional questions, you can refer to the speaker bio box containing contact information for Troy or myself. And lastly, of course, I want to thank everyone for attending this webinar from Design World. This presentation will be emailed to everyone later today and will also be available at www.designworldonline.com.